So this is problem 31, chapter 21 of Giancoli 6th edition. And it's a problem about transformer. The derivation of the equations for the transformer is done in the problem 36. Okay, so you can go to problem 36 if you want to review that. But okay, so this problem is giving us the number of turns in the primary coil, and the number of turns in the primary coil is larger than the number of turns in the secondary. Okay, so they give us these two numbers, and we know that the number of the primary is larger than the number of the secondary, and that the question is, what kind of transformer is this? Well, if the number of turns decrease, we know it is a step down. Okay, we know it's a step down. What we'll do is it will decrease the voltage. Okay? Now, by what factor does it change the voltage? So they want to know what is the ratio between the voltage in the secondary and the voltage in the primary. Okay, as I said, you can either go to the book, go to the notes, or go to problem 36 to remind yourself how to derive these equations. But what is important to remember is that voltage, EMF, is proportional to the number of loops, to the number of turns. So we know that what we have to put here is the number of turns in the secondary divided by the number of the turns in the primary. Okay, so from here you're going to find this ratio. Now the other question is, what is the ratio between the current? So the next question is, by what factor does it change the current? So they want to know the ratio of the secondary current divided by the current in the primary. Now, this is just the opposite. Okay, so it's the number of turns in the primary divided by the number in the turns in the secondary. How are you going to remember that? Remember the equation for power. Power is IV. So we have IPVP equals to ISVS. So you see that the ratio here, let's pick the ratio between the voltage, VS divided by VP, gives us IP divided by IS. Okay? So whatever happens to this ratio will happen to this other one. So here I have secondary divided by primary, here I have primary divided by secondary, so that's why things get upside down when you're dealing with the current. And that's the end of this problem.